Hello everybody. Okay, so in this video we are looking at second order difference equations. So first order difference equations were recurrence relations where we only required the one term. So a second order difference equation is a recurrence relation where we require two terms. So a second order difference equation is a recurrence relation where each term depends on the two previous terms. For example, Tn equals 4 times Tn minus 1 plus 5 times Tn minus 2, i.e. to get the next term, we multiply the previous term by 4, multiply the term before that by 5, and add them together. So there are two types of difference equations. Second order difference equations. There are homogeneous difference equations and inhomogeneous difference equations. So in this video, we are just going to be looking at an homogeneous difference equation. And a homogeneous difference equation is just a difference equation that only contains terms of the sequence like Tn minus 1, etc., and no additional constants or functions. So for example, Tn is equal to 2 Tn minus 1 minus Tn minus 2. That is known as homogeneous. So homogeneous just means all the same. So we're only working with term values here. While inhomogeneous difference equation includes extra terms such as constants or functions of n. So for example, Tn equals 2 times Tn minus 1 minus Tn minus 2 plus 7. This is what makes it inhomogeneous because not everything is a term value. Same over here. This is the same term, but I have a 6n, right? So that is what makes it inhomogeneous. But in this video today, we are only looking at homogeneous second order equations. So first things first, we need to, right, find the characteristic equation of my difference equation. And what is my characteristic equation? So we identify the term number and assign them powers of x. So what we do is we treat the lowest term. It's usually un, but it might always be, it might be un minus 2, right? And then we treat that as a constant. So we let that equal 1. And then we increase the powers of x step by step. So for an example, if I see un, I make that 1. If I see un plus 1, I make that x. If I see un plus 2, I make that x squared, right? So I keep increasing the powers of x. And then we write the characteristic equation. So we use the coefficients from the original equation to form them. So for example, this one here, un plus 1 plus 3un minus un minus 1. This one would be, this is my lowest term value. So that would be 1. So 9 times 1 is 9. Plus 3un, that's 1 up, so that'll be 3x. And then un plus 1, that's 2 steps up, so it'll be x squared. So this one would be x squared plus 3x minus 9. This one here would be x squared equals 6x minus 5, right? I'm decreasing in powers of x when I'm going down term values. This one here, this one will be x squared minus 10x plus 25. This one here would be 6x squared minus 2x minus 1 equals 0. And this one here, x squared equals 8x minus 15. These are known as characteristic equations. So why do we need to have a characteristic equation? So we need to get the characteristic equation of my homogeneous second order equation. Then we need to find the roots of that the roots of that quadratic. And depending on what the roots are, we have two distinct formula, right? If they are two distinct roots, right, the general solution for my second order difference equation would be some constant L. It doesn't matter what you use. You could use capital A, capital B. You can use L and M. It doesn't matter what you use, but it's going to be a constant L times one of the roots to the power of n plus m times the other root to the power of n. That's if we have two distinct roots. And if it's not a distinct root, if it's a repeated root, then my general solution looks like un equals L times the root to the power of n plus m times n times the root to the power of n. Right? So let's have a look at solving one of these now. So what we do is we write the characteristic equation of my we write the characteristic equation, right, of my difference equation. We solve the characteristic equation for the two roots. Then we apply whichever general solution applies. So if it's a repeated root, we do L times the root to the power of n plus mn times the root to the power of n. If the two distinct roots, it's just L times the root to the power of n plus m times the root to the power of n. And then using our initial values that were given in the question, we're going to make then a simultaneous equation of L and m, and then we solve them to figure out my general solution. So it's no point in me kind of talking about it. Let's start doing one here. So solve the following difference equation. Vn plus 2 minus 7Vn plus 1 plus 12Vn equals 0, where V0 equals 4 and V1 equals 10. So first things first, I need to find my characteristic equation. And my characteristic equation here is going to be x squared minus 7x plus 12. So Vn is my lowest term value. So that becomes 1. This one becomes x. This one becomes x squared equals 0. Solve this. Two numbers are multiplied to get 12, but add to get minus 7 are minus 3 and minus 4. Therefore, my two roots are x equals 4 and x equals 3. There are my two roots. So step 2. Sub into general solution. Right? So my general solution here is going to be Vn is equal to L times one of my roots, so 4 to the power of n, plus m times the other root to the power of n. Again, you don't have to use L and m. You can use capital A and capital B. If you prefer, use capital A, capital B. You can use L, you can use m. You can use whatever you prefer, but I'm just doing L and m. Why not? Okay, now I use my two initial values. So step 3. Sub in initial values. So V0 equals 4 and V1 equals 10. So V0 equals 4. So Vn is equal to 4 when n is equal to 0. So I'm going to have 4 equals L times 4 to the 0 plus m times 3 to the 0. Anything to the power of 0 is 1. So this would just be L times 1 plus m times 1, which is just L plus m. There is my first equation. And my second equation, V1 is equal to 10. Well, n is equal to 1 when Vn is equal to 10. So I'm going to have 10 is equal to L times 4 to the power of 1 plus m times 3 to the power of 1. So I'm left 10 is equal to 4L plus 3m. And there is my second equation. And now all I have to do here is I just need to solve them simultaneously. And when I solve them simultaneously, I'm going to multiply my, so that's equation 1, that's equation 2. I'm going to multiply the first equation by negative 3. So minus 3L minus 3m equals minus 12. 4L plus 3m equals 10. Add these up. I'm going to get L equals minus 2. L equals minus 2. Sub in to find m. So 4 equals L plus m. 4 is equal to minus 2 plus m. M is equal to 6. So therefore, my general solution is going to be sub it back all the way up here. It's going to be minus 2 times 4 to the power of n plus 6 times 3 to the power. And that is my general solution there. Now, the second part is find V8, the 8th term. So to find V8, I just sub in n is equal to 8. So it'll be minus 2 times 4 to the 8 plus 6 times 3 to the 8. And if you put them in the calculator, you should get minus 91,706. That is the 8th term. Let's look at another example here. Solve the difference equation, wn plus 2 minus 6 wn plus 1 plus n wn equals 0, where w0 equals to 5 and w1 is equal to 30. So my difference equation, or my characteristic equation, going to be x squared minus 6x plus 9 equals 0. Two numbers that multiply to get 9 but add to get minus 6 are x minus 3, x minus 3. Therefore, x equals 3, x equals 3. What we notice here is these are equal roots. Therefore, I apply my general solution. So Vn is going to be equal to L times 3 to the n plus m times n times 3 to the n. So step 2, apply initial conditions. So V0 is equal to 5, V1 is equal to 30. So, W0. So W0 is equal to 5. So when n equals 0, Wn is equal to 5. So it's going to be 5 is equal to L times 3 to the n. Well, 3 to the power of 0. 3 to the power of 0 is 1, so it's going to be L. And then m times 0 times 3 to the power of 0. Well, I'm multiplying everything by 0 here, so that's going to be 0. So I have L is equal to 5. And then let's look at my other one. W1 is equal to 30. So when n equals 1, Wn is equal to 30. And I know L is equal to 5. So I have 30 equals L times 3 to the power of 1. We know L is equal to 5. Plus m times 1 times 3 to the power of 1. So this is going to be 15. Bring that over. 15 is equal to 3m. Therefore, m is equal to 5 as well. Therefore, then, Wn is equal to 5 times 3 to the n plus 5 times n times 3 the n. And that is my general solution there. And then if I'm asked to find W8, i.e. the 8th term, that's what I'm asked to find here, find the 8th term, that's just going to be 5 times 3, 8, plus 5 times 8 times 3 to the 8. W8 is going to be equal to 295,245. 8th term of the second order difference equation. Right. I hope this video was some help to you guys. So in next video, we're going to be looking at inhomogeneous difference equations. I hope it was some help, and I'll catch you guys later. Bye.